Now let's take those guidelines that we just went over and actually go through some examples. And again, in these first two examples, we're going to be using that critical value method here. So if you need those guidelines with you, you can have them nearby to kind of go through the different steps, and we'll go through these steps together here as well. So our first step is to basically do that requirement and that background check, right? To see sigma should not be known here, so we're going to have to use a t-distribution, but we do need to check the sample size or that the population is normal. So I'm going to read through the problem. I see a used car dealer says that the mean price of used cars sold in the last 12 months is at least $21,000. You suspect this claim is incorrect and find a random sample of 14 used cars sold in the last 12 months. And that sample has a mean price of $19,189 and a standard deviation of 2950. Now, this 2950 standard deviation is from the sample. It's not from a population. Is there enough evidence to reject the dealer's claim? At alpha is 0.05, and we are going to assume the population is normally distributed. So that first step, we're going to notice that sigma is unknown here, right? That would be the population standard deviation. My sample size is very small. It's only 14, so it's definitely not greater than 30 or greater, but I am told the population is normal. So even though I have a small sample size, I can continue on with the problem. The second thing we're going to do, and again, you can go back to your little checklist here, is to define the claim, the null, and alternative hypotheses. So if I read through, again, we're talking about evidence to reject the dealer's claim. So the dealer is saying that the mean price of used cars sold is at least $21,000. So $21,000 is the minimum. So our claim here is that the mean is greater than or equal to $21,000. Now, remember the null hypothesis always has to have some sort of equality. So it happens in this case that our claim is the null. And then the opposite of this would be less than. Okay, so remember, your null hypothesis always has some equal piece to it, whether it is greater than or equal to, less than or equal to, or actually equal to. And your alternative is always going to have either strict less than or greater than or not equal to as their symbols. The third step is to define the level of significance, which is your alpha. So we're told our alpha here is 0.05. And then the fourth step is to find the degrees of freedom, which is n-1. Our n here is 14, so 14 minus 1 is 13. Now, the fifth and sixth step, and again, I'm just kind of going back here to my guidelines from the page of 4, are about finding those critical values, finding those rejection regions. So I'm going to do this at the same time. And I'm going to, draw my picture here. Now, with sigma unknown, we are using a t-distribution, but it still has a mean of 0. It still has that basic bell shape, although it's not exactly the normal curve. It's a little bit different. And the other thing we need to know is what kind of test this is. So that part's kind of left out here, but you need to know what kind of test it is. So if I look at my alternative hypothesis, I do see I have a less than sign. So a less than sign means that we have a left-tailed test. So you can tell your tests from your alternative hypothesis, right? So again, as a review here, if you see a greater than, then you would have a right-tailed test. And if you see a not equal to, you would have a, sorry, that says two-tailed test. So you're looking at that alternative hypothesis. So here I'm using a left-tailed test. So that whole alpha is going to be on that left side here. Okay. And what I need to do is I need to find what this t-value is. It is going to be a negative, right, because it's to the left of 0. So I do need to find that out. Now, we can do this in a few different ways. You can either use your calculator. So if you use your calculator, you're doing second bars inverse t, And remember, the area is always on the left. So the area to the left of our value here is 0.05. And next you have your degrees of freedom, which is 13. So if you're using your calculator, this is the piece that you're doing. Let's bring my calculator up here. .05, comma 13. And I get a t-value of approximately negative 1.771 if I go ahead and round that to 3 decimal places. Typically for the t-values, we tend to use 3 decimal places. If I don't like using my calculator, you can use table 5 in your text. So table 5, let me see if I can show you on camera without putting too much stuff around. So here's table 5, sorry, I'm moving it over here. So we do need to know our degrees of freedom is 13, and we also need to know that we have a one-tail test here, right? Because there's only coloring on one side, and the alpha is 0.05. So I'm looking at the one-tail alpha, so that would be 0.05, and then I'm going down to degrees of freedom 13, which you can see is 1.771. So that's the other way that you can do that. And it is a reminder that if you have a left-tailed test, just remember that it's a negative. So it's not going to be positive 1.771. You're just going to use the negative version. So that's how you can use the table here. All right, and the shaded area is our critical or rejection region here. So the next thing we need to do, part 7, is to go ahead and find that test statistic. So you're using the formula, the sample mean minus the population mean over S divided by the square root of N. So here our sample mean, I do have to go back up here, is 19,185. Oh, 189, excuse me. The mu, the population mean, comes from your hypothesis. So it's 21,000. Your sample standard deviation is 2950. And your N here is 14. So if you go ahead and subtract and divide everything out, what you should get is about negative 2.297. So once we have that, we're going to go back up to our table here and see where this value lies. Now, our critical T here, right, or that rejection region for our T, is negative 1.771. Now, this value is smaller than that, right? Let's get a different color here. What about yellow? So this value is smaller. It's going to be somewhere over here. So that value definitely lies in that rejection region, right? So what we're going to end up doing here, and this is the last few steps, is we are going to reject the null hypothesis. And again, this is because it lies in that rejection region. So we're rejecting the null hypothesis. And just keep in mind, the null hypothesis happened to be our claim here. So we are rejecting the null hypothesis. So since that happened to be our claim, we must also be rejecting the claim. So there is enough evidence to reject the dealer's claim here that the mean is at least 21,000. All right, let's try one more. So we're going to do the critical value method. So an industrial company claims that the mean pH level of water in a nearby river is 6.8. So here's our claim. The mean is 6.8. You randomly select 39 water samples and measure the pH of each. So let's just say the sample mean and the standard deviation are 6.7 and 0.03 respectively. Is there enough evidence to reject the company's claim at alpha equals 0.05? So first of all, know that we do not have any information about the population here. So we're going to use our t-distribution. Our n is 39, which is greater than or equal to 30. So we are all set. Because again, I don't have any background information about the population. Now we're going to set up our claim. So our claim is that the mean is 6.8. Now, your null hypothesis always has some sort of equal sign. So in this case, your claim happens to also be the null. And your alternative is the opposite. So the opposite of equals is not equals here. Again, you don't want to make any assumptions about greater than or less than if none of them are stated in the problem. So if there's no wording that implies greater than or less than, something like that, then you are likely using not equals there for your opposite. The third thing is we just note our alpha. So our alpha is 0.05 again. And then we also have to talk about our degrees of freedom. So in this case, we're looking at 39 minus 1, which is 38. Oops, sorry about that. So now we're going to go ahead and start drawing our picture. My center is at 0. Now, notice here that my alternative hypothesis has a not equal sign. So we have a two-tailed test here, which means that I'm going to have a critical region on each side. And this is supposed to be symmetric, so I know it doesn't look perfect, but we have the same amount on each side. So we have one value here, and we have one value here. Now our alpha is 0.05. So because I have two tails, I'm going to cut that alpha in half, and I'm going to use 0.025. So this side has 0.025, which is half of alpha, and this side has 0.025. And those shaded areas are our rejection regions. So what I have to do is I have to find those t-values. And again, you can do it using the table, or you can do it with your calculator. So if I do my calculator, again, you're doing the area to the left. So for this one, the area to the left is pretty easy. It's just 0.025. And then you're doing the degrees of freedom, which is 38. For the other side, and you don't really have to do both sides, because it's going to be symmetric, but if you want to, you just want to be careful here. The area to the left is going to be all of this plus this. So what you have is actually 1 minus this value. So sometimes the right side is a little bit harder to find. You just have to think about what the area is there. All right, so let's see what I get for my two values. So I'm going to inverse t here, and I'm going to do 0.025, comma 38 first. I get about negative 2.024, and then I'm going to do it again. 0.975, comma 38, oops, 38, and I get positive 2.024. So again, I feel pretty good that they're the same value, right? They should be the same value on each side. So I can do both of them to check. If you want to use the table, just bring that table over again. Now remember here that we have two tails and our original alpha was 0.05, right? So here I'm looking at two tails and my original alpha was 0.05. So I'm in this column here, and I need to go all the way down to 38. And when I do that, let's see. There's my value. You can see it, the 2.0. 024. So that same value that we were getting. Now remember, your table only gives you the positive value, so here I'll have to put one positive and one negative to keep that balanced. Okay, so or table 5. Your next step is to find the test statistic. So again, this is called the test statistic. So our mean here was 6.7, and we're testing the value of 6.8 for the mu. Our sample size was 39, and our, oh, sorry, I wrote this backwards. Our sample size was 39, that goes under root n, sorry about that. Then our standard deviation is 0.035, 0.35, excuse me. Now I'm going to go ahead, I'm going to divide all that out. Let me go back to my notes here. We get about negative 1.784. So first of all, keep in mind what your original values are here. So our cutoff value for this one is negative 2.024. So this is negative 2.024, so these values are smaller, these values are bigger. Now, this value here is definitely bigger. So my test statistic is like right here, 1.784. So it's not in that critical region or in the rejection region. So because of that, we do not reject the null hypothesis, or you say we fail to reject the null hypothesis. That's the correct wording that you see. So thinking about what's going on here, we're going to fail to reject the null, meaning we're not going to reject the null. So we're kind of saying like we're keeping the null. Again, we're not proving it, but we're saying like, yeah, so far it looks fine. Doesn't seem to be anything wrong with it. So we're kind of hanging on to that null, which means at this point, since the null is our claim, we're saying that right now there doesn't seem anything wrong with the claim. Again, I'm not proving it, but at this point in time, I don't see any issues. It seems to make sense. So in this case, we do know that there is not enough evidence then to reject the claim in this case, right? So the claim was the null. We did not reject the null. So at this point, I cannot reject the claim.